Um, a couple things here. One, I did send you guys some notes online, and one of the notes that I sent you, here's Kaneko. Someone else talking right now because I'm getting some pretty
Hadley
significant. Okay, was there someone's video on or something?
I guess she's probably down at HBU right now, dialing into the class.
Oh, gotcha. Oh, hey there. Hey, Hadley. All right. In your notes, there's something called balancing equations, and there's a 2-page of front and back that you guys can probably find if you wanted to. You can look it up on your computer. I'd still want to have your faces, but if you don't have it, if you don't have a printed version of it, you might want to get a copy of it onto your screen. Do you guys know what I'm talking about here? Give me a head bob if you know the worksheet I'm talking about. It looks like I'll put it on my screen real quick just so you guys can see. It looks like that. Let me I'm going to screen share with just that's it right there. Yeah. So in case you're having trouble finding it, I'm just going to share this real quick. You guys can see it on my screen. Although he has it there, but this is the worksheet, and this is the statements we're going to make, and then this is the practice worksheet that you guys are going to be doing for homework on your own after you watch some videos. So here's the basic introduction, and I'm going to do it just as if we're talking as friends. I'm going to get rid of the screen share because it's going to start looping on us. All right, you with me right now, Payson?
Yes, sir.
Okay. Normally I'd ask you guys, what is the law of conservation? But I know in your minds you're all desperate to say the law of conservation of matter, isn't it that all matter can either be created or destroyed? You can give me a head bob there. I do still crave responses. I'm still needy that way. So that means this: if matter can't be created or destroyed, and all matter is made up of atoms, doesn't it make sense that atoms can't be created or destroyed? So our job right now is going to be really simple. All we're going to do is we're going to take equations, and we're going to try and make sure that we've balanced the correct number of atoms on either side. So let's do a real basic one. Can you write on the board for me, Mr. Scribe person? Can you write N2? N as in Nancy, sorry. N as in Nancy. Although that is interesting, you went for the only possible symbol that does not represent an element in any way. N2 plus H2. Leave a little bit of space in front if you don't mind. Your handwriting's neat. That's really good. Leave a little space because we're going to start using coefficients. H2, and then put an arrow and write NH3. Okay, so here's the deal. If we looked at the number of atoms on each side, you can quickly check, and wouldn't you agree that there's 2 N's on one side and only 1 N on the other side? Boy, this is really close to my face. I'm sorry you have to look at me at that particular angle. Not flattering for anyone. So the only thing we are capable of doing, the only thing we can do, is we can only mess with coefficients. What you can't do, and I want you to, Payson, I want you to be really sneaky right now. So you pretend like you're stealthy. Okay. Are you pretending to be stealthy? I don't know what stealthy looks like, but I feel like there needs to be more sneakiness involved. But I want you to very sneakily go over to the N on the right-hand side, and I want you to put a little coefficient of 2 down below. Okay. No, not. I'm sorry, I misspoke. Not a coefficient, because you just did things correctly. Erase that. I want you to do it incorrectly. I'm trying to prove a point, but this is evidently terrible. Let's try it on the other side of the N.
Oh.
All right. Now, what he just did is he just created some monstrosity of a compound that doesn't exist. Like if I were there, I'd smack his hand if that was legal and I wouldn't go to jail. There's no way you can ever change the subscripts in a formula. Are you all with me on this? So whenever you want to balance something, subscripts are forbidden. Can I get a head bob around the room? Or a thumbs up? I need to know that you're with me. Are you talking or not talking here, Payson? What's happening?
Parker's computer is about to die.
So while I did that, you should never, ever put a subscript in. So let's get rid of that too down below. Thank you. And what he really did was he jumped ahead and did what you're supposed to do, which I guess I probably should have applauded instead of making him do it incorrectly. You can only use coefficients. So we can put coefficients in front of anything, right? But in this case, since we have 2 N's on the left-hand side and we have 1 N on the right-hand side, wouldn't it make sense to put 2 in front of the N on the NH3? So let's put a 2 in front of there. In future times, just to make it visually pleasing, why don't you use a different color pen for the coefficients, just so it makes it fun. I'll let Sarah choose what color pen you should. Oh, you already done it. All right, there we go. Now, that's great and all. And if you take a look at the number of n's on the left-hand side and the right-hand side, put your finger on the n on the left-hand side. There's 2. So that the subscript counts as 2. And there's also 2 there. But that 2 does not just apply to the n, right? Doesn't it also apply to the number of hydrogens we have? And we already have 3 hydrogens there. So it's kind of like when you do coefficients in mathematics. When you put a coefficient in front of something, it applies to everything that's behind it. So that 2 not only applies to the n, it also applies to the 3 h's. So that's going to be 2 times 3. Isn't that 6 hydrogens we have on the right-hand side? He jumped the gun and did it. Y'all with me? Y'all with him? And if you did the math, and one of the things that we're going to do always is, and unfortunately, the way that we try and do balancing equations and such, it's called balance by inspection. And that's just a fancy way of us not wanting to say, hey, you got to do trial and error. But that's essentially what we have to do when we're doing them. Now, this here is pretty straightforward because as soon as you change one coefficient, you change another coefficient, and you're done. But one of the things that you're going to discover as you do more and more of these is that as you do these, if you change one of the coefficients, it may make the other coefficients wrong. So you may have to go back and forth a little bit, which nobody likes to do. Any questions right now? Right. So if you can read the rules here on the sheet itself here, because I don't have them in front of me and I don't want to go back and forth. Payson, will you read in the clear voice? Actually, just jump down to the rules at the bottom.
Okay. You may never mess with the compound structure by changing its subscripts.
Okay, pause. Isn't that what I tried to make him do?
Mm.
And then I was like, no, don't do that. Never mess with the coefficients. 2.
You are free to change coefficients in order to balance.
Okay. So that's what we did, right? 3.
Start with the atoms that are only in one compound on each side. Try to tackle the most complex atoms, or the most atoms first. Okay, so if you take a look at this equation that he wrote on the board, there's not a whole lot of stuff going on there, right? There's just things that appear in one place only. But we're going to deal with a couple more complex ones, and you're going to see that there's going to be times where you have an n in 2 or 3 different places, or you have an o in more than one spot. And those are always harder to do because if you have an o in 2 spots and you have an o in 1 spot, how do you divide up? So let's picture this in your head. Can you picture just right up on the top of the board? Let's say we had 10 O's on the so 10, and let's make it, instead of 10 O's, let's go 10 ALs. Okay, so we have 10 ALs on that side, right? And put an arrow, and then write AL, and then like a squiggle line, like a squiggle going horizontal. That's representing some sort of compound. And then actually, so AL, as if you're going to write another letter next to the AL, but we don't know what it is. So I'm leaving that in the space of it. Brilliant. And then plus AL and another squiggle line. Okay. Now, if I tell you have 10 ALs on the left-hand side, right? And you have AL in 2 places on the right-hand side, aren't there a pretty numerous number of possibilities of which coefficients we can put in front of each AL? Can I go 5 and 5, or 4 and 6, or 3 and 7? Can I get a head bob around the room if that makes sense? I'm all staring at every one of you, so I know who's not head bobbing at me right now. All right, thank you. So what we're trying to do is, if you take a look at that, if you ever see something on one place on one side of the equation, can you touch the 10 AL on that left-hand side? And on the other side of the equation, you have AL in 2 different spots. You want to leave that to the very end to balance, because hopefully by itself, it'll balance itself. Can I get a head bob on that? So let's try something that's a little more challenging. So let's erase everything. And we're going to use a, and incidentally, if you kept on reading in the list, is one of the things say if you have polyatomic ions, you can treat them as a single unit? Yes, that was the next rule.
Keep on reading the rest of them through, and then I'll work through.
When possible, treat polyatomic ions as a single unit instead of breaking them apart into their individual atoms.
Mm-hmm.
Leave oxygen and hydrogen until the very end. And always double check after balancing to make sure that you have the same number of atoms on each side.
That's good. That's good. All right. So we're going to do an example of that right now. And the equation we're going to do is, I'm making this up on the spot. So right up as high as you can without, like, yeah. Let's go Mn CO3. And then leave some space, plus
Ag NO3 yields Mn NO3 in parentheses 2 only the NO3 in parentheses plus Ag2 CO3. Okay, so what you see we've done here is I've given you an equation, and there's a whole bunch of atoms. And if you notice, aren't there oxygens in more than one compound on both sides? Yeah. And do you see how, yeah, multiple places. And you also could see that if you were to try and balance, it's not balanced the way it's written, right? At the very start, I'm looking at it and I see that I have an N, only one N on the left-hand side. Don't I have, can you put your finger on the right-hand side, Mn, NO3? Put your finger on the N. Okay, see that N is multiplied by 2 because that 2 is multiplied by everything in the parentheses. And that O, which there's 3 O's right there, isn't that also multiplied by 2? That's 6 O's. Now, let me ask you this. If we were to multiply each of the individual atoms out, wouldn't we have a whole bunch of O's and N's and whatever just randomly strewn about? So in this case, because we have polyatomic ions in the compound on both sides, we can actually treat the polyatomic ions as if they're single units. For example, let's take a look at which do you think is the most complex one on the board? Which is the ugliest of all the formulas you put on there? That one. Okay, let's take a look at that one. So we're going to start with Mn NO3 in parentheses 2. So put your finger on the Mn. How many Mn's are on that side? 1. How many Mn's are on the other side? 1. So we don't have to worry about the Mn. Agree? Now let's take a look at the NO3. Now watch. Isn't there an NO3 on the left-hand side? An entire unit of NO3? Put your finger on the NO3 on the left-hand side. There's an NO3 there. And since we have an NO3 on that side, and then we have 2 NO3s on the other side, we're not going to split them apart to make 2N, 6O, etc. We're just going to treat them as NO3s. Can I get a head bob here? So if I have 2 NO3s on that side and only 1 NO3 on the left-hand side, can we put a 2 in front of that whole thing to make it, oh, nice, even change color. Brilliant. Wouldn't that mean that we now have 2 NO3s? So everything on the MnNO3, can you put your finger back on the right-hand side? Everything on that is now balanced off. Agree? You have a question? Anyone have a question? Okay. By the way, if you have a question on anything, just type in a question and I'll help you with it. Now, go back. Here's the problem is where you put the 2, that 2 did not just apply to the NO3, did it? Did it also apply to the Ag? Which is kind of cool because don't we have 2 Ags on the other side as well now? So if we take a look at the AgNO3, isn't it balanced with the MnO3? Now let's take a look at the MnCO3 at the front. Isn't there one Mn on this side and one Mn on the other side? How about CO3s? One CO3 and one CO3? Looks like we have everything balanced. Now, the last step is one that's kind of important because in this case, we didn't have to go back and forth, but in some cases you will. So if that's the case, as soon as you're balanced, you need to go back and just do a math add up again. So why don't we just go each one and just make sure we have one MnO. Yep, I like that. Actually, it should be just one CO3 when we're doing carbonate. Yeah. And then one NO3, right? And then one Mn, two. There's 2, you're right. And then 1. And do me a favor, just do little loopies to match them up. Like from the 1 to the 1, like underneath there. Yeah, 1 to 1. Why is that? Why did he change that to a 2? Because of the coefficient in the front, right? Now, what he just did there is way more work than you have to do. You don't need to be making loopy lines across everything. That's just silliness, right? But that's how we do it. Any questions? All right. It is fairly straightforward, and I'm gonna nerd it up right now. I like these because we're gonna give you some problems where you actually have to go back and forth a couple of times. And when you change the variables on one side, it's going to change the variables on the other side, and you're going to have to rework them. So I like doing that. Some of you guys may not find it as enjoyable as I do. Let's try a different problem. Let's try one more. Let's go C2 H6 plus O2 goes to CO2 plus H2O. Okay. So if you take a look at this right here, the question is, which one do we want to start with? Are we going to want to start with the O's or the H's? Probably not, right? We always want to start with the more complex one. So wouldn't the most complex one be the C2H6? Okay. Now, if we look at that, I have 2 carbons there. Don't I have 1 carbon on the other side? So fair enough. Can't we just put a 2 in front of the CO2? Knowing, of course, the 2 impacts the O2 as well, right? Now, we have 6 H's, don't we, on the left-hand side? How many H's do I have on the right-hand side? 2, right? So can I put a 3 in front of the H2? You see that he resists the urge to change the coefficients because, or the subscripts, because that's just forbidden, right? Now, all is good, right? Except for one thing. How many O's do we have on the left-hand side? Left-hand side, we have 2. How many O's do we have on the right-hand side?
5.
Try again. So put your finger on the 2 in front of the CO2, please. That 2 times that, isn't that 4 O's? And then don't we have a 3 in front of that? Isn't that 3? Isn't that 7 O's altogether? So on the left-hand side, we have 2 O's. On the right-hand side, we have 7 O's. That's a problem for us, right? So would you agree that if we were allowed, like you can't have half of an atom, but if we were to have half an atom, couldn't we multiply the O2 on the left by 3.5? Do it. Just put 3.5 in front of it. Knowing you can't leave it there, but just put 3.5. Now, if I put the 3.5 there, would you all agree that everything is balanced off? Except for the horrible fact that we've just decided that we can chop a molecule of O2 in half, which is not great, right? So here's the hint. When you ever get to a scenario like that, can't we just multiply everything by 2 to get rid of the half? Do you all follow that here? So we're just going to multiply everything by 2. And that, not just that equation, so it'll be 2 in front of that. 7. Or was it, what did we have there originally? Was that 3.5?
Yeah.
So you have to multiply what's originally there. And it might help you to do it down below just so you don't screw this up. There was a 3.5 there originally, right? Okay. Does everyone see right now? That's the numbers we have. If we're going to multiply by 2, we have to multiply all of the coefficients by 2 as they are. Now, the first one only has, so can you put a big parenthesis around the whole thing? The whole equation? And then go times 2. And then before you go any farther, can you throw that orange pen as far away as possible because I cannot see anything with it? Yeah. Except this probably shouldn't throw away good stuff. So we'll pick it up later, but we'll pretend like that was a cool moment for us. All right. So could we multiply that all up by 2? And can you come in the new coefficients? Okay. So it'll be 2, 7, 4, and 6. And let's get rid of that 2 on the outside now. Is everyone okay with that? Can you give me a thumbs up if that made sense? Now, let me give you a hint here. What I just showed you is something called a combustion reaction. Next class period, I'm going to teach you how reactions work. And that's one of the more fun things I get to do because that leads us into all kinds of reaction stuff that we're going to work with. But this is called a combustion reaction. And combustion reactions are always done with a hydrocarbon. Can you put your finger on the C2H6? See how we call that a hydrocarbon because, and wait for it, it's just carbons and hydrogens in it, right? Whenever we put a hydrocarbon with oxygen, this reaction always occurs, always, always. Now, here's my hint for you. If you ever have an even number of carbons in your hydrocarbon, see it's 2, so you'll see C2H6, C4H8, or H10, C6, whatever. If it's ever an even number, in order to help yourself balancing, put a 2 in front of the compound to begin with, and it'll make your problem really simple. This is just a trick. You can go the way I just did, but the short way would be just to put a 2 in front of it. Okay. Now, any questions for me on this? Now, take a look at the worksheet page, and I'm going to share my screen with you. So I want you all look at the screen that I have right now, so you can all look at the same equation. You can also pull it up there. Let's. The worksheet is online and it's also in the classroom. I think someone printed it out for you, but it's in your folder, the shared folder. Okay, it looks like this, and it's found in your yeah. And we're gonna go to this worksheet right here. It's 2 pages. The front page is notes, and this is the second page right here. So these are all. And by the way, a few of you guys are gonna have questions because you're gonna look at this and go, wait, the AL right here doesn't have an underscore right there. And what do I do? It doesn't matter if there's a space or not. You have to put coefficients, and it may help you, even though you don't need to put a 1 in front of something, even though there's no reason to put a 1 in front of it. But I want to point out something here at the very bottom. Can you guys see on problems 18 and problems 24? So 18, will you write what you see, Payson, will you write 18 CaSO4 with a little asterisk 2H2O on the board? Okay, so what that is that's something called a hydrate. Okay, and a hydrate, I'm doing a screen share still, so I'm going to get rid of this. Stop it so it's not. Okay, so what that means is any coefficient you put in front of that is going to apply to everything. So if you take a look at the very front, so let's say we put a 2 in front of the CaSO4, so in a different color. Put a 2 in front of the CaSO4. So what that means is I have, and wait for it here, put your finger on the Ca. I have 2 Cas. I have 2 SO4s. Now watch. Isn't that 2 times, and put your finger on the 2H2O? Isn't that 2 H2Os on that side? But the coefficient in front means I'm multiplying that 2 by the 2 in front of that. So that means I have 4 H2Os. If you wanted to break it down even farther, well, don't write it in there like that. No. So putting the 2 in front, you can't, remember how we said we can't change the actual subscripts? You cannot change a coefficient in the middle of something, okay? So what that means is there's 2 problems that appear like that. And if you ever have a little asterisk, the coefficient in the very front, I'm pointing at my screen as if you can see this. It's crazy, I'm so dumb. The coefficient that you put in front of that is gonna apply to everything, including the coefficients in front of the H2O, okay? Now, that only applies to a couple problems. Now, what I'll suggest to you, and if you go back to the worksheet, let's take a look at that just briefly. I'm gonna screen share the worksheet again with you. Okay, if you take a look at the very first problem, okay, so you have KNO3 and it goes to KNO2 plus O2. Now, all of us will acknowledge that NO3 is nitrate, but we don't have a nitrate on the product side. We have an NO2 and an O2. So we can't cancel out an NO3 with an NO2. So in this case, we're actually going to have to break apart our N's and our O's to solve this. And the other thing I want you to be aware of when you're going through this worksheet is that as you're moving through some of these problems, you're going to have to go back and forth quite a bit. So let me go back here. So get used to the fact that you might be able to, let me say hi. You want to say hi to my son? Hola, Pichon. Hi. Say hi, everybody. Say, dile hola. Hola.
¿Quién es? I think he's trying to talk to you.
Are you muted, Payson?
No.
Okay. My son now is, you are the most interesting person that he's ever seen.
No, now the shoes are.
Now shoes are. Anyway, so. That's appropriate response. I couldn't even get, thank you, Hadley. God bless you, as always is the case for that. All right. So I'm going to, what I did is you guys were not going to, Jackson not to be outdone. Appreciate that. What I'm going to do right now is I'm going to let you guys work. Now, what was supposed to be done in class is I gave you a bunch of videos to watch. Do you guys remember you have the thing that I gave you before? Now, I would suggest at least watching the first guy or so because he's pretty good. Let me see this really quickly. This right here, so I hear someone else that just jumped in. So watch. Let me show you that. I realize I'm not screen sharing.
Oxygen molecule.
So let me show you on the actual screen, and I'm going to share just for a second so you guys can see what I have on my screen. If you're unmuted, mute yourself back up. So this is, if you can see right here on my screen, this is from Khan Academy, and these are the 4 things that I kind of wanted you to do. It kind of walks you through balancing stuff. If I had not been here, then this would have been all you had to work through. But these are kind of practice, and then at the very end they have a practice balancing where you plug in numbers here, and it gives you 7 problems to try and work through. So that's what was expected to be done prior to you doing the worksheet. Now that being said, you're going to hold up in front of me here. Hold up 1 finger through 4. 4 being I understood 100% completely everything that we understood here. 1 being I am kind of weak on this completely. 2 or 3 meaning I'm ish. Hold up a number of fingers in front of you. So I see some 2s, I see some 3s, I see some 4s, I see a couple 1s or 1. All right. So here's what I'm suggesting here. I'm going to get rid of the screen share real quick. Your homework is that worksheet. That's the only thing I'm going to grade. But I want you to look through the video, at least the first video. The guy's actually really good at reiterating balancing, and particularly, I'm looking at the ceiling right now, Payson. Thanks. It's the balancing equations worksheet is the homework. That's the second page of that, and I will try and put an answer key online for you, or I'll send it in, one of the 2. But the videos I want you to watch and just try them through. If you're the only class that I actually jump back in to be able to do this with, so. All right. Any questions for me here? Anyone? Okay. Let me also mention a couple things here. So obviously there was a test that was taken while I was gone. Who here did not take the test? Okay. And I think it's only musical people that I need to be dealing with right now. So what I'm going to do is, it's so good to see you guys again. I've been going stir crazy in my home. I'm going to be gone another week. So this is how we're going to do lecture for the next. I don't know what you're doing there, but yeah, thanks. It's going to be how we do lecture for the next week at least. I think this can be effective as long as I have someone that's willing to step up there and help on the board. But do me a favor here, do the assignments in between class. And what I may do, just check your email and such. Oh, on the portal. So let me show you this really quickly. I'm going to screen share with you. So what's going to happen is that every day, so we're not going to have Tong coming in here thanks, that's very sweet. We're not have Tom coming out here to show you what to do. So if you take a look at this is, let me go to your class. So you guys are pre-AP B4. Payson, can you see this right now? Because I can't recall.
Yes.
Okay. So if you can see this right now, this is now my new portal. So this right here is where you have your notes and everything. So that's the shared link that I gave you before. This right here, Sarah says, this is the link to today's lecture right here. Every morning or every afternoon, whenever we're getting ready to come to class, you're going to click on this link. Okay, that's going to show you. That's going to take you to the page that we just did. So, like, if I were to click on this right now, it would try and open me up in the window that you guys are just in. This right here, when you click on this is going to take you to all the videos that would have already been shown. So this is the archive page, so the playlist. You're going to have access to this playlist. So what you can do is, if you ever miss a lecture or whatnot, or you want to go back over and see what we did, you're just going to click on that link and it'll take you to it. So just to recap, this link right here, the link to today's lecture, that will be a changing link every class period because I'm creating a new video every class when we do this. So don't just like go, all right, I got it, and then try and click into that link because that link will be a dead link as soon as I stop broadcasting. This link right here will be an archive of all the lessons that we have. All right. Let me get back to you guys here and turn off screen sharing. All right, any questions for me here? Okay, so the remainder of class, you guys are going to work on the balancing equation worksheet. It should be pretty straightforward. I mean, you should be able to finish that. Some of them are embrace the nerdiness of it. Some of them are a pain to do because you have to go back and forth. But to me, again, I will acknowledge fully that I'm nerdistine here. I like puzzles. So whenever I had something balanced on one side and unbalanced on the other side, I kind of found that cool. And I kept on going back and forth. You may find it incredibly frustrating. Now, what you need to be aware of here is if you like, I can't balance this. Balancing is the worst thing in the history of all time. You're just making me busy right now. You okay?
Me?
Yeah, you're creating an earthquake, or I don't know what you were doing there with me moving your thing up and down. What I would suggest doing is looking back and making sure you've not mathed incorrectly. I used math as a verb there. So like if you like decide you have 6 oxygens and really you have 5 oxygens, hate to break it to you, but it's going to make your entire problem incredibly terrible. Yeah. So that being said, I'm going to say goodbye to you all. The only people I want to talk to are Hadley and the people that are at the musical. So I'm gonna have you guys just shut out of your window. It is really good to see you guys again. I can't wait to be back at school, believe it or not. And I'm really bad right now at responding to emails because I'm on painkillers. So I should stop broadcasting. Anyway, I'll talk to you guys soon.